done and the readiness of these projects to you all. We start with Professor Nalin Shah, Professor Tata, IIT Bombay, who will be talking about his project, the study of pre-treatment, biochemical and steam of cotton stalks for beneficiation as animal feed.
Good afternoon. For those who were there in the earlier session, I'm shifting gears now. I'm coming to the nuts and bolts now. In the workshop in the morning, you had a larger picture of food agriculture. So one such project on commodity-based research, as we call it, this is on cotton stalks. So for those of you who do not know what is cotton stalk is a material that is left after you remove the bolls of cotton. So currently what is happening is with these cotton stalks is see, something like 43 million tons is available throughout the country if you see the recent figures, the recent data. So most of it is human. All of you would have heard about the Delhi pollution, and people complain that agriculture residues burn and the emissions and smokes and all that creates that kind of a smog. And that is what is happening in Vidarbha region of Maharashtra, where there is a lot of cotton which is grown because there's no sort of market value as such. So farmers find it much easier to get rid of it by burning. Okay, so there is some use of late. There are some 20-30 plants which make densified fuel or briquettes, pelletize it, and they generate a revenue of something like 5,000 to 6,000 rupees per ton of this commodity because it burns well. But what we are sort of proposing is that the animal feed, which is sold at something like 20 to 25 rupees per ton, so which is 15 to 25 rupees per kilo, and therefore there is a 4 times value addition if you can use this cotton stalk as an animal feed. And in many of these areas, people sort of, in fact, in the other parts of Maharashtra, people grow the fodder crops, and in fact, in the second crop, what we call as Rabi, more preference or more revenue is coming not from the ear heads of the crop, but as the stem part of the plant, because which is sold as a fodder. So if this can work as a fodder, nothing like it. But the problem with cotton stalk was it has very high lignin content, something like 25%. So when it gets dry, it becomes like wood. So animals don't eat it. It's very hard. And it was kind of a, I would say, close to a serendipity that we used, for example, ozone to make it soft, because earlier we had worked in food preservation, something on tomatoes, and ozone had done the trick. And the ozone generation costs have come down. So I said, let us try this cotton stalk, because when the problem was thrown open to us, that how can we use this cotton stalk and convert it into animal feed? Can we try ozone? And to our good luck or good fortune, we could break that lignin and cellulose bond, and therefore it became softer. And then we had done some kind of a studies in the lab subsequently, what we call really as the in vitro studies before we went into the in vivo studies. In the lab, we found that the digestibility went up from 40% to 60%. So the veterinary people, the way they do, exactly we did that in the lab, and when we saw that there is a good enhancement in digestibility quotient of that particular material of this cotton stalk, then we are in the process of doing the in vivo trials with the help of a veterinary college in Nagpur, and they are doing it from the small ruminants like goats. Right now that is happening, and I'll depict all that in a small video. I was advised by my colleagues and doctor to speak less, so I have a video, and I'll show you through a video what we did and what we are in the process of doing. We have actually planned a demonstration unit, for example, subsequently as a kind of a translation of this research, because right now we have done it with the small ruminants like goats, and we want to do it with an NGO called BIAF, which is very active in these states, which is working on animal husbandry, and we will put up such a plant and we will test this shortly. So these are some of our lab results I mentioned. 40% to 60% we went from non-treated to treated stalks, and here is the process that we suggest. So we shred the stalk first, and then soak into the water overnight, ozone it for 5 hours, sun dry it, and mix with concentrates and pelletization. Because animal nutrition has gone up. I mean, even multinationals like Hindustan Liver, they were there in this kind of a business. So there is a good linear programming also available, that here is something, a nutrition you want, we can put it in concentrates, we can put in roughages, and you can mix and come out with this. So there is all that business model that we want to sort of work with concentrates and sort of pelletizing it. And of late, what is happening, this is again a spin-off effect that we have of this particular project, that a lot of goateries are coming from the government side to sort of promote this as a secondary source of income for people. So because goat, you can sell it as a meat, and there is a good sort of economic proposition that it makes, and how we can sort of make these kinds of pellets. And so this is the process. You have a Cotton-stalks, for example, then you have a ozone plant that we have put up in Nagpur Veterinary College, treat it, then we sort of make the mix it with the concentrates, make the pellets, and feed it to the goats, as you can see here. So let us see that through a sort of a video clip, that what we have done. If you can minimize this and go to the video. And the video, in a sense, talks about lab results, our pilot plant results, and what we plan to do subsequently.
We narrate to you a story of converting cotton stalks into animal feed. India produces about 43 million tons of cotton stalk every year. Currently, cotton farmers all across Maharashtra, and particularly in Vidarbha region, simply burn it on field, and small portion is converted into fuel briquettes. Animal-based foods, both milk and meat, provides nutritional needs of Indians, as well as it provides additional income to farmers. The practitioners as well as veterinarians clearly observe that stall-fed animal husbandry is more productive compared to field grazing. This has enhanced demand for formulated feed. Data in recent years indicates demand of 67 million tons of feed. Since cotton stalks are hard, animals do not eat it. Research experiments at IIT Bombay using ozone breaks lignocellulosic bond and makes it softer. This project allowed in vitro studies on cotton stalk that yielded digestibility enhancement from 40 to 60%. Towards in vivo trials on goats, a feed production facility has been set up at Nagpur Veterinary College. Pelletization allows uniform formulation of roughage and concentrates. Initial trials on goats gave very encouraging indications of animals relishing the formulated feed. The research team is now in the process of evaluating quantitative response to the formulated feed towards weight gain and productivity. As cotton crop is spread over large distances and stalks have very low bulk density, collection at centralized location is challenging. Another challenge is techno-economics for commercialization. A business model covering collection, formulation containing concentrate and roughage, pelletization and distribution needs to be worked out in association with the stakeholders such as farmers and farmer producer companies.
Yeah, I think that narrated better than what I spoke. Okay, thank you.
2 minutes for questions. Questions, please.
Yeah.
Ozone reaction time is very high. So why you
In the sense that perhaps the chemistry that explains that in order to break that lignin and cellulose bond, you require a good amount of residence time. You know, actually it turns out good for us because the half-life of ozone or the ozone in air is there for only 9 hours. Then it shifts back from O3 to O2. So if you have ozone in water, for example, within 12 hours you will sort of see that it's all converted into oxygen. Therefore, you had that packaged drinking water which says that 300% oxygen. Remember, there was a big controversy that there was a company which made the packaged drinking water and claimed that our water has 300% oxygen because they ozonated it and it converted back to oxygen.
I think residence time is less than that, not 12 hours.
Shelf life, as we say, or we say the half-life of ozone in air and water are in that order. But it required, I mean, we did several experiments and found such. We would be nice if we can devise some mass transfer mechanism by which it can be reduced. But it turns out okay because overnight you can soak it and then treat it.
What is the temperature at which it was done?
Ambient. So this was done at ambient
So
temperature.
at higher temperature
It might dissolve faster,
in case you need to
accelerate or something.
Yes,
Yeah.
please.
But as a part of protocol, we find it's okay overnight. Yeah. So right now we have done the lab trials. So this particular ozone is 100 grams per hour, the one which the generator that we have. So, and ozone generation costs have come down really drastically because a lot of water treatment people, as I was mentioning to Professor Vishal, and then swimming pool, for example, water treatment, you have to ozonate. So you can have right from like 35 grams per hour to 100. Our plant is 100 grams per hour. So that decides the capacities. We have a 500-liter tank, syntax tank, where we soak the cotton stalk and treat it. Yeah. But we are going to work it on a scale up because the NGO has expressed interest in doing it. Yeah?
What is the change in a texture and tonality?
Thoda louder. Yeah.
What's the change in the texture and
Texture of
The
cotton
stalks.
stalk, there is no practically any change in texture. I mean, if you mean color or something,
No, I feel like when the
it becomes softer.
okay,
It becomes
apart from that any other like,
no other change, because we have soaked and also we have ozonated, so it has become softer. So that's why the goats, which they untreated one they didn't eat, but treated one they eat. So, and that's intended change. No texture change we didn't. We thought that as long as the goats are eating and the animals would eat, we didn't want to do any mechanical. I mean, you can always use universal testing machines to find its breaking strength and all that. One can do, I mean, estimate the numbers. But we didn't do it because we said the first proof of concept was the animals eat it. Yeah. Thank you.